Good day. So what we was looking at previously would have been some of the basic statistical diagrams that we had, the bar graph, the pie charts, and those were pretty straightforward and simple with a regular frequency table. Now we're going on to different kind of data. So just to remind you what the old data would have looked like, this will be one of the questions that we did when we was looking at the bar graph. So we have the age of the students. It was a small sample, so that why it was a little easier to do. But as we move along in statistics, what if I wanted the age, everybody in Trinidad and Tobago, and I want to know how much people in that age group or that particular age. So you'll realize that, and again, I just started at 15. Remember, I could have started at 0. So look, I go in 15, 16, 17, 18, 19. Look, I reach 40. I went to the next page already, and I stop at 60. But obviously, we have people up to age 100 plus in Trinidad. So this data becomes pretty tedious to keep watching all of this data. The table can't even fit on a page. Imagine how long that table is going to be. So what we have is these new terms, which we call a distribution now. We're going to come across some new terms that are going to help this data be presented a little bit easier. So the first term is the class interval, and I'll upload this, scan it and upload it and put it on Google Docs, send you on via email, send you on WhatsApp as well, whichever one you can access. We're going to look at the class interval first. So that's one of the new terms you're going to come across. This enables the data to be represented and interpreted in a much simpler way. So for example, watch here. So instead of saying how much 15-year-olds they have, which was 7, 16, 17, 18, now I could group all of them together. So I want to group more 15 to 19-year-olds. And again, the group size will vary, and it have a name for the group size you'll see when we're looking at. I just using the group size from 15 to 19, and you'll see this in a lot of surveys. If you're doing an online survey, there's grouped in the ages together. Very infrequently, they might have all the ages in a drop-down box. So instead of saying 15, how much, 16, how much, I'm going to group all of them together. And because I group the ages together, I'm going to group these together. So 13 add 7 is 25, 28. Right? We don't care about this number so much right now. I'm just showing you how they'll group it. So all of a sudden, my table shrink by a factor of 5. Because what was taking up 5 lines, now taking up 1. And I continue like that. Here it could be 20 to 24, and then 25 to 29, and to be a pattern, if you notice, 15, 20, 25, 30, 35, and here and all will increase by the same amount, 19 at 5, 24, 29, 34. So you're realizing the table already going to get smaller by a factor of 5 and might be able to actually fit. And again, we could choose a different interval. This here is what we call the interval. So this was just to explain. I'm coming back to my sheet now just to show you what's it going to look like. So the interval would be a way to make the data easier and simpler to interpret and read. So I will say 49 to 49, 45 to 49 years. Now instead of saying 45, 46, 47, 48, 49, I group everybody into an interval and make 1 line instead of 5. And again, we could use different sizes of intervals. We can make 10 lines into 1 line. We can make 3 lines into 1 line. The question will determine how we do that though, right? It's just showing you what this means. And then we could continue the pattern, 50 to 54 years, 55 to 59, and so on. So this is what we'll call an interval. Is really a range of values it covering instead of individual values. So that'll be an example of what a class interval is. And we're going to use that now to explain the other term. The limits are just the n values at each of the intervals. We call those the limits. Now we have 2 n values. 49 is the n value. 49 is the n value. 46, 47, 48, the in-between numbers are not n values. So we call the lower number, the smaller number, the lower limit or lower class limit, and the larger number, the upper class limit. So I'm just going to write it back, 45 to 49, 50 to 54. We're just using these 3 examples to explain these new terms. We just look at the class interval, which is this range of values that shorten the information now. And in each interval, we're going to have a first number and a last number. We call the first number the lower limits. So these are limits, by the way, right? That's what this one is. So we call the first number the lower limit or lower class limits that are shortened as LCL, not to write out sometimes. And the larger number we call the upper limit. So for big and small, in terms of this graphing terminology, we're using upper and lower for big and small. Same thing here. So you realize each interval going to have 2 limits. The smaller one going to be the lower limits, and the larger one going to be the upper limits. And same thing here. This is going to be your lower class limit. Again, I just write in LCL for lower class limit. This one going to be your upper class limit. That's what we call the limits. The end values are the intervals. The boundaries related to the limits, but most of the time we was using age just now. What if we were going to use height or weight? Something that don't have an exact value. Sometimes when you measure somebody's height or weight, it might have a 0.5 or decimal answer. This is to account for that depending on where they fall in. So for the boundaries, again, we're still going to use the example of the 45 to 49, 50 to 54. I'm writing again, better people, hopefully soon. 55 to 59. So in my interval, we already say we have a lower limit and an upper limit. To get the boundaries, it accounts for the decimal answers if we have to round off. So for the boundaries, this is going to be 0.5 less than the lower limit. So I'm going to minus 50 cents from the lower number, or a half from the lower number, whichever you want to use. So $45 take away 50 cents, because that's what 0.5 means. So I'm going to end up with 44.5. That 0.5 we call the lower boundary. So the boundaries will always have a 0.5 attached to it. So we call that the boundary now. Meaning, if my foot size was 44.7, whatever the units I was using, when I round up 44.7 or 44.5 or 44.6, it's going to round up to 45. So that's why we kind of taking that margin of error kind of stuff. The upper boundary, the upper limit, we add 0.5 to get the upper boundary. So 49 at 50 cents, 49.5 or $49.50. You can see the dot there. We call this the upper boundary. Realize again they're using upper for big, lower for smaller number, right? So once it's a boundary, you have to take away 0.5 or a half from the lower number, add 0.5 to the upper number. And again, if I was 49.4, when I round off 49.4, because you gotta do rounding off and approximations already, closer to 49 than to 50. So that's how we do the boundaries. The boundaries are a little more confusing than the limits. So same thing here, I minus off my 0.5. You don't have to put your minus in off the 0.5. I'm just showing you how we get in the answer. Add the 0.5. So here going to be now $50, take away 50 cents, 49.5. And here going to be 54.5. So here going to be the lower class boundary. Again, I just write in LCB, so I have to write out lower boundary all the time. And upper class boundary. And again, I write the terms here, right, to show you what the UCB and LCB going to be. And you realize now, he stopped off at 49.5 and he's starting back at 49.5. So they have no gap in my graph for continuity when I'm trying to do it. Same thing for this last piece here now. Again, I'm minusing off my 0.5, 50 cents. So he's going to be wherever this one stop off, you realize. So 54.5. I'm going to add here. So he's going to be 59.5. And again, the smaller number will be the lower boundary or lower class boundary that I was shortening as LCB. And the bigger number going to be the upper boundary. So the boundary different from the limit because it's going to be 0.5 less than the lower limit and 0.5 more than the upper limit. So again, these are some of the new terms you're going to come across. So far we have interval, limit, boundary. The next one is one of the easier ones, is the class width or the class size. That's how big the interval is. It have a formula for it, but they have easier ways to do it. So again, let me write back out the example we using was 45 to 49, 50 to 54, 55 to 59, and I'll show you 3 different ways to get the class size or the class width. You might use those 2 names interchangeably. So if I wanted the class width, they actually have a formula. They say the formula is take the upper boundary of this limits and the lower boundary and subtract them. So if you're going to use the formula, which is the hardest way to use it, the upper boundary for this interval was 49.5. We have that from before. Minus, because the formula is upper boundary minus lower boundary, 44.5. Sorry for that line in the page. Hope you can see it. So 49.50 minus 45.50, I'm going to get a nice smooth 5. But they have an easier way to get the interval. The interval really covering, telling me how much numbers it's covering. So if you used to actually look at this, the interval covering from 50 to 54, meaning 50, 51, 52, 53, 54. How much ever numbers it covering, that's the class width. So it's covering 1, 2, 3, 4, 5 numbers. I get my 5. I didn't need any fancy formula for it. They have a next way I could do it as well. If I was to watch the pattern it jumping by, and then I could use the pattern to predict what coming next. It was increasing by 5 each time. It jumped by 5. 20 at 5, 25. So each time it was jumping by 5 on both sides, if you notice. So because it jumping by 5 each time, the pattern is 5. That's telling me how much it's jumping by here as well. As you can notice, it jumped by 5, 45 at 5, 50 at 55. Same thing here. Add 5, add 5. So because I'm jumping by 5, it's telling me how it's spaced out. How much the width that it's spaced out is at. The last one, and you can see here the class width is the same. You realize I just showed you 3 different ways, but once I find the class width once, that will be the same class width for the entire question. They could only ask it once. The class width will be the same. So the last one you have to look at, the last new term, is the midpoint. And what midpoint means is the middle. So again, I'm going to put my trusty examples from before. So those were the 3 that we were looking at. To get the midpoint, what I'm going to do is add the 2 end numbers and divide by 2. So I'm finding the average, something we had doing statistics before. So I'm going to add 45 at 49 and divide by 2. So that is 94 over 2. So the middle number is 47. Or in other words, 45, 46, 47, 48, 49, 47, 49 and 45 pay off, 46 and 48 pay off, and I end up with my middle. The number in the middle, the midpoint, right? Almost like the median. And I could do the same thing here. 50 add 54 over 2. Again, 104 over 2. But once I get it once, or I get 2 numbers in a row, I don't need to keep adding and thing. I mean, it's simple to do, but it have a faster way. Remember we said the numbers jumping in 5s? Well, these numbers jump in by 5 as well because it's related. So once you find the pattern, you could just continue the pattern and you don't have to keep doing this, but you need to start it off at least to get the first one. So 52 at 5, the next number going to be 57. And if I was to do our next one, again, he will be add 5, 55 at 5, 60, 59 at 5, 64. And if I was to add 5, again, 62. So you realize I don't need to go through 60 at 64 divided by 2. I could save a little time, and time important. And just like that, we could go backwards. We just keep going forward. What if we was to go backwards in the interval? What if I wanted the interval before 45 to 49? So if I'm going backwards, meaning I want to go this way now, I subtract 5 instead. So 45 minus 5, he go be 40 to 49 minus 5, 44. And the midpoint go be 47 minus 5, 42. So I could go that way as well. Why we need the midpoint though? I don't know if you recall, I'm just turning back here quickly. When we were doing this one in particular, remember when I wanted to find the mean of the table, I multiply out my table to get the totals. How am I going to find the mean of these numbers? Because remember, it's a range I have now, so to be a little harder. So we use the midpoint as an estimated value at that interval, and now we'll multiply out this by whatever the frequency was, and you'll get an estimated answer, as you'll see when we're going to look at one of those examples from the worksheet in a little while.